Alrighty. So let's learn how to solve some quadratic equations. We're going to use what we know about square roots from yesterday. This question is asking, what do we square to get 36? Well, there's two things. 6 would work, -6 would also work. Got an answer. Okay. So that's easy enough. People just usually forget about the negative. And they'll be like, well, it's the square root of 36. Well, the square root of 36 is 6 and -6. The principal square root of 36 is 6. Like if you actually see the square root on a sheet of paper, that's when it's 6. When you're just finding the square root of 36, you're finding anything that you can square and get 36. So there's two of them. And this time, there is no square root on that sheet of paper. It's just plus or minus 6. So same thing here. What do I square to get this? Well, it's either a positive or negative, whatever the square root of 72 is. And 72 is 36 times 2. So we got that. Okay, same deal here. Like this just stands for numbers. What do you square to get 79? To get 49? Well, either positive or -7. But that just means what was this number? Like that x minus 3 was either positive or -7. So x, add 3 to both sides. 3 plus 7 is 10. 3 minus 7 is -4. Same thing here. What do I square to get -28? Or sorry, to get 28? Well, whatever that number is that I'm squaring is either positive or negative. The square root of 28. Add the 6 to both sides. 28 is 4 times 7. Square root of 4 is 2. And then I just stop right there. Because what that means is it's either 6 plus 2 root 7 or it's 6 minus 2 root 7. But either way, you can't make that look any better. So people just leave 6 plus or minus 2 root 7. It looks strange to write the plus or minus out front. People just don't do it. So that's why I put the 6 in the front of it. Before we get going here, I'm going to move this around. Now I'm going to do, what do I square to get 16? Either positive or -4. So 2 plus or minus 4. 2 plus 4 is 6. 2 minus 4 is -2. Okay. So those are bad. If you have a square in a problem that you're trying to solve for the variable, don't get rid of the square. The square is good. Yeah. All right. And then right here, we're going to, I guess, ways to factor. Number one is you factor out the greatest common factor. And this is always the first way to factor. Like you need to do this before you do anything else. So 9 and 36. What's the biggest number that goes into them both? 9. They don't both have an x, so we can't take that out. But what do you do? If you factor out the 9, it leaves x plus 36 divided by 9, 4. And notice if you multiply that back out, 9x plus 36. Pretty much when you're factoring, you're taking it from, so like right here, something plus something else. You're taking it from sums and differences back to a product. Because like when you do 2 times 3 is 6. The numbers that you multiply to get another number, those are called the factors. So if we're doing something on factoring, it's you're turning it back into what did I multiply to get this? It's basically, okay, I need to get more sleep. I even slept an hour later this morning than usual. Apparently it did not help. Okay, so it's the distributive property reverse because you're getting it back to what did it look like before I distributed the 9 out. But it does turn into a multiplying problem. You get 9 times something else. Okay, this one, you don't have to take the negative out, but I find that whatever, like if I write things in descending order, biggest powers first, it is helpful to get that biggest power term positive after you factor it. So like, I would definitely take the negative out. 3 to 15 both divide by 3. K squared and K will both divide by K. So I'm going to factor out a negative 3K, which will leave just 1K here. Now, because I factored out a negative, I'd have to have a negative here. It's a positive divided by a negative. So negative times negative gets me the positive. And then I took the K, 15 divided by 3, it's 5. And you can check. There's negative 3K squared plus 15K. Yep. This one's 16 and 4. Biggest thing that goes in both of them is 4. I could take P cubed out because P cubes in both. So I need a 4P plus 1. Yep, we're good. All right, so those first 3 are just factoring the GCF. Okay. Now we're up to trinomials with a lead coefficient of 1. Okay. Well, to see how to factor those, let's actually multiply one out. Let's say you got 2 binomials multiplied together. Here's x squared. Negative 4x and positive 3x give me negative x. And here, I won't do it in my head. Minus 12. So you get x squared minus x minus 12. So look at the numbers that we're sitting here. Well, first, x times x. You needed that to get this. Okay. The back number is those 2 times by each other. And then so it's like the A, B, C. So the C is like the 2 back ends of those binomials multiplied together. And this happened because you added those together. Negative 4 and 3 make negative 1. And those both were the coefficients on the x's. So what I'm looking for to factor a trinomial where the front numbers are 1 is I'm looking for 2 binomials. I need 2 numbers that multiply to be 7 and that add up to be 8. Well, 1 and 7. Multiply to be 7, add to be 8. Positive 1 and positive 7. And then you can check b squared. 7b and 1b makes the 8b. There's the 7. Yep, that's it. So trinomial, lead coefficients 1. We want 2 numbers that multiply to be 50, add up to be negative 15. So if they multiply to be positive 50, they have to be the same sign. They're either both positive or both negative. If they add up to be negative 15, you know they're both negative. And then 5 and 10 will multiply to be the 50. And then negative 5 and negative 10 multiply to be 50, add up to be negative 15. And we got it. Okay. So those 2 were just trinomials with lead coefficient 1. All right. This third way, which usually you learn this before the other one, but that's okay, is a difference of 2 squares. So let me just show you what happens. Well, actually, I guess we could look at it like it looks like the ones before because there's 0 x's. So you could totally think about it this way. I need, because that makes it a trinomial with lead coefficient of 1, I need numbers that multiply to be negative 169 and then add it to be 0. Well, 169, the square of that's 13. If I had a 13 and a negative 13, it would work. But you don't want to have to go through that every time. Because to get that 0x, there's not going to be an x term in here, the linear term. Do you notice that we did is x, x, that got to be the x squared. This and this were the opposites, so they get the 0, and then minus 169. So if you've got just anything where you do like plus 2x minus 2, that'll give you x squared minus 2x plus 2x, that's gone, minus 4. Okay, so we want to get to where we can just start by seeing, oh, I have a difference of two things that are perfect squares. And it will always factor down into two binomials, get multiplied together. One will be a sum and one will be a difference. And then you just always ask yourself, what did I square to get a squared? That's the first. What did I square to get b squared? That's the backs. So it's just a recognition thing. So this one, do you have a difference? Yes. Is everything here a perfect square and everything here a perfect square? Yes. This is a difference of two squares. It's going to be two parentheses, one sum, one difference. What'd you square to get 49x squared? 7x. What'd you square to get 81? A 9. That's it. Okay, but like right here, go back to way number 1. Ways to factor. Greatest common factor first. So on this one, before I do anything else, I'm going to say, all right, let's take a 9 out, because 81 and 9 both divide by 9. X is 6, x to the 4th. I can take the x to the 4th out. That's going to leave a 9x squared minus 1. So I've already factored this. This is the difference of two squares. One's a plus, one's a minus. What did I square to get 9x squared? That's 3x. What did I square to get 1? Now, if you hadn't factored the greatest common factor first and just looked at it and go, oh, those are still perfect squares, because they are. I could do a sum and a difference. What did I square to get 81? 9. What did I square to get x to the 6? That'd be an x cubed. So that'd be the front term. What did I square to get 9x to the 4th? That'd be a 3x squared. But then each one of those would have a greatest common factor. So like I'd have to go, let's take the 3x squared out of here. That'll leave a 3x plus 1. Let's take the 3x squared out of here, and it'll leave a 3x minus 1. Then the 3x squared times the 3x squared gives me the 9x to the 4th. So you get to the same place. It's just a whole lot quicker if you just take it to begin with. Okay? All right, and then solving by factoring. We've actually been doing this when we were working with the parabolas in the intercept form. Because if I just give you some random fact, it says 2 things add up to 0, that is useless. There's infinitely many ways we can add up 2 things, or 3 things, or 4 things, or however many things, and get 0. But if I said you had a number times another number equals 0, totally helpful. One of those 2 numbers is 0. So that's what we want to do. That's one of the benefits of factoring. There's lots, but that's a major one. Right now, this is a difference. Something minus something else gives me 0. That's worthless. Okay? But if I could factor it, take the 4x out, that leaves an x minus 4. Now it's useful, because what I'm saying is 4 times whatever x is times whatever x minus 4 is gives me 0. So one of these 3 factors is a 0. Well, it's not this one. Okay? It could be that one if x were 0. And it could be this one if x were 4. And you got it. Okay? So again, something minus something plus something equals 0, useless. If it's factored, though, and this is a trinomial with a lead coefficient of 1, let's put the x's. What do you multiply to get 4? Add up to get negative 5. That'd be a negative 4 and a negative 1. So what makes x minus 4 0? Positive 4 does. What makes x minus 1 0? Positive 1 does. Look at it. Okay? Now, even if you factored it, saying sometimes something equals a negative 5, again, totally useless. because there's infinitely many ways I can multiply and get negative 5. I need that to be a 0 always. So if you're trying to solve these and it's not set equal to 0, add that 5 to both sides and then look at it again. It's like, okay, what multiplies to be 24 adds up to be negative 11. That'd be a negative 8 and a negative 3. That means x is either 8 or 3. Same thing here. Subtract 6 from both sides. So it's set equal to 0. What multiplies to be negative 18 adds up to be 3. That's going to be what, a positive 6 and a negative 3? Then you got your answers. And again, you can always check them. Like if you plug negative 6 in for n. 36 minus 18 minus 12. 18. Yep, that worked. If I put the 3 in. 18. That works too. Okay. All right. That's a good place to stop.